Alright guys, if you try to do the homework assignment from today, this should look familiar. Well, those are the same problems. Your assignment for tomorrow is going to be to look at this video, listen to me explaining how to do those problems, and then tell me what the problem was with yours. So basically I want you to look at this, solve this one more time, and then compare it to what you did, and then tell me what went wrong, okay? So again, if you had trouble with this, it's okay. Those are very difficult examples, and I didn't just want to show you. I wanted you to take a look, and some of you started this really well, but in general, I know that those give you trouble. So the first one, we want to find the derivative of a trigonometric function that has a square root with it. So on the side right here, I'm going to write myself a couple reminders. So if I had a function that is y is equal to x to the power of 3 only, what would I do to find the derivative? I would bring the 3 in front, I would put the x and raise it to the power of 2, right? Now the next thing, what if I had x squared plus 1 to the power of 3? Well, if I wanted to find the derivative, I would say, okay, I will put the 3 right there. I am not going to change this. I'm going to raise it to the power of 2, and then I am going to multiply it by the derivative of the inside. And then you can clean it up and then go from there. Well, this one is going to be even more difficult, and you will see in a second, and those 3 examples are similar to each other, so I hope you will pick up what the pattern here is. So the first thing I'm going to do is I'm going to write this in a little bit different form, and I hope you agree with me that this is correct. So I have an expression that is raised to the 3rd power. So now if I want to find the derivative of it, I am going to say, well, I can kind of follow this track, and I can say I am going to have 3 times sine of square root of 4x plus 1. I am going to raise it to the power of 2. I am reducing or lowering one exponent, and I am going to multiply it by whatever the derivative of this is. To find the derivative of this, we know that derivative of sine is cosine. Whenever it's not just a cosine of x, you will continue writing whatever we have there. So in our case, it's 4x plus 1. And then next, we are going to multiply it by the derivative of whatever that inner function is. In our case, that inner function is, I'm going to write this kind of on the side here. So I have 4x plus 1 to the power of 1 over 2. So the inner function, so if I want to solve this, that is going to give me 1/2 4x plus 1 to the power of negative 1 over 2, but then I still have to multiply it by the derivative of inside, which in this case is 4. Pretty amazing stuff, right? Think about this for a second. And of course we need to clean this up a little bit. So what can I do? I have half, and I have 4, that's 2. I have 2 times 3, that's 6. And then I have the sine. I can put the square here, or I could keep it the way I had it, 4x plus 1. I have cosine of 4x plus 1. I took care of those numbers, and because this is negative 1/2, I am going to put this in the denominator as a square root of 4x plus 1. Done. I don't think we can, I don't think we can simplify anything else. This looks pretty good to me. All right, we'll do the next one. And the next one will get even a little, even more complicated, but then on the bright side, the next two are going to be a little bit easier. So I want you to remember this. If I wanted to write this as two function, my f of x function would be 3 over x, and my g of x function would be this entire mess. Square root of tangent of 4x squared plus 1. All right, now let's find the derivatives of each. So the derivative of this one is, well, that is going to give me 0 minus derivative of this is 1 times what is on the top, and then x squared. And then derivative of the g function is going to be a little bit longer. So again, I will keep in mind that this is raising it to the power of 1/2. So I am going to bring 1/2 in front. And then I am going to have tangent of 4x squared plus 1 to the power of -1/2. And unfortunately, I don't have a room, so I will just continue writing. I know that the derivative of tangent is secant squared of whatever we have here, so 4x squared plus 1. And I need to multiply it by the derivative of inside, which in this case is 8x. All right, so we have our chain rule set up for us. And now we can go back and find the derivative of the g function. So the derivative of the g function is going to be -3. In place of x, we always plug in the g function. And that's square root, but we are squaring that because of this. And then we are going to multiply it by definition by the derivative of the g function. So I am just going to look quickly here. I can simplify 2 and 8, that is 4. So I am going to have 4x, and then this tangent is on the bottom. So it's going to be square root of tangent of 4x squared plus 1. And the secant is on the top of the fraction. Every time I say bottom or the top of the fraction, I think of my math teacher who would get so upset. In her eyes, you would have to say either numerator or the denominator. It was never okay to say the top or the bottom of the fraction. Well, she was a really good teacher too. -3 times 4 is going to give me -12x. And then I have the secant squared, 4x squared plus 1. And I'm going to divide it by, now notice this is squared, so this is going to take care of the square root. So I'm just going to have tangent of 4x squared plus 1 times that square root of tangent 4x squared plus 1, done. Well, I hope you enjoyed this one. As I said, it was a little bit more complicated. I will scan those notes, but I will still ask you to write them down. The last two are going to be a little bit faster. So I have product, and in order to find the derivative, I'm going to find the derivative of the first one, which is 2x. I'm going to multiply it by the second one that is not that I am not going to change, and then I'm going to say plus, and I need to find the derivative of this. So this is what we were doing yesterday, and maybe some of you picked this pattern up already. -3 to the power of 1/2. We will, to find the derivative, we will bring 1/2 2x minus 3 to the -1/2. And then we will multiply it by 2 because we want the derivative of the inside. So 2 and 2 will cancel out. So it looks like the derivative of this is going to be 1 over square root of 2x minus 3. And then I would have to multiply it by the term that I have right there, so which is x squared plus 1. If you catch any mistake of mine, please let me know. One should ask, is this simplified enough? Yes, at this point it is. Somebody could ask you to either put this on a common line or maybe rationalize the denominator, but again, for us, this is done. And then we have the last one, and the last one is going to be like, oh, that's really not bad. So what I need is I need to know what is the, and I am going through my notes, tangent secant squared. So I know that tangent, if f of x is equal to tangent of x, then derivative of this is secant squared of x, secant squared of x, yes. All right, so now, well, let's see. We have a square, so I'm going to bring the 2 in front. I'm going to have tangent of 3x to the first power. And then I still have to multiply it by the derivative of this. And the derivative of this is secant squared of 3x times the derivative of inside, which is 3. To clean it up, 6 tangent 3x secant squared of 3x, done. Well, I hope you won't find any mistakes, but if there's anything that you are questioning here, anything that I possibly might have made a mistake, or anything that you might not necessarily agree with, please let me know. Again, please remember those are difficult examples, and I am trying to show you skills that are required for calculus. So you will see this calculus class next year is going to be easy for you. But on top of what we are doing now, you will learn so much more. Enjoy your weekend. Maybe I will see some of you during my office hours tomorrow. Otherwise, I'll be proud of yourself for doing this amazing math. And have a great day.